This lesson is going to be on how to add expressions. We want to know what the sum is of 72.3x minus 45 and 12.6x. So sum, I know, means to add. So to keep everything clear, I'm going to group my expressions in parentheses to show that it's two different expressions being added. So I have 72.3x minus 45, that's one expression, plus this other expression of 12.6x. Even though it's just one term, it's still an expression. Now I need to get rid of my parentheses. There's no number in front of this first expression to distribute, so I can just remove it from the parentheses. 72.3x minus 45. This plus sign in front of the other parentheses, we would look at that as an imaginary positive 1. So I could distribute my positive 1 to get 12.6x. Now I can combine my like terms. 72.3x and a positive 12.6x. When I combine those, I have 84.9x, and then this minus 45 doesn't have any like terms, so that's just going to come down as minus 45. Simplify this expression. Same thing, we have two expressions, each having two terms. You have to simplify it, get rid of the parentheses. There's no number in front of this parentheses to worry about, so I just bring it down. 9.7c minus 250. In front of this other parentheses, though, I now have this positive 2. So I can distribute that positive 2 to each of the terms inside the parentheses. Positive 2 times negative 5.4p is negative 10.8p. Positive 2 times a positive 123.6 is a positive 247.2c. Now I look for my like terms. 9.7c and a positive 247.2 are like terms. So I can combine those to give me 256.9c. Negative 250 does not have any like terms, so that's just going to come down. Negative 10.8p does not have any like terms, so that can just come down as well. And you want to write your answer with your variable terms in alphabetical order. So I have 256.9c minus 10.8p minus 250. Sophia and Olive each deposit means they're putting it into their account, $120 to open a joint account. Sophia deposits $150 each month and Olive deposits $130 each month. Write an expression to represent the amount deposited by each person after m months. So for Sophia, since she deposits $120 to start and then $150 each month, that's $120 plus $150m. Olive deposits the $120 as well, but she only deposits $130 each month, so it'd be $130m. The second part wants to know the amount in the joint account combined after m months. So to do that, I'm going to add both expressions. So I'm going to group them in parentheses to make it clear that it's two expressions being added. 120 plus 150m plus, for Olive, 120 plus 130m. Nothing in front of this first parentheses to distribute, so I just bring it down. 120 plus 150m imaginary positive 1 in front of my other parentheses. So I could distribute, gives me a positive 120, positive 130m. Combine my like terms. 120 plus 120 is 240, positive 150m, and a positive 130m. Combined to give me a positive 280m. And you want to write your expression with the variable term coming first. So 280m plus 240. And task 4. Joel spent $28 for an internet data service plan and pays $14.50 per month. He spent $24.50 to join an online movie streaming site and pays $13.25 per month. Write an expression to represent his total cost for both memberships after m months. So for the internet data service plan, we're going to group that in parentheses. That's $28 plus the $14.50 or 14.5 per month, which is m. Plus now, because we want to know the cost for both memberships, the online movie streaming service, which is $24.50 plus $13.25 m, because it's each month. Nothing in front of the first parentheses, so I can just bring that down. 28 plus 14.5 m. No number here, but imaginary positive 1, which I can distribute to give me a positive 24.5 and a positive 13.25 m. Combine my like terms, positive 14.5 m and positive 13.25 m. I picked those first because I knew my variable terms have to come first. That would give me 27.75 m, and 28 plus 24.5 combines to give us a positive 52.5. So this expression would represent his total cost for both memberships after m months.